Oh, what's up, guys? I forgot to do complex math, which I wanted to do last time. Um, I guess I can also do um just basic conditionals, whether they're true or not. I'm not gonna do ifs and thens in this tutorial, but um, I'll just do like is 3 greater than 2, and I'll shoot off true. And I can do it the other way around, say false. This will lead up to, I want to do a while loop next, which is an iteration loop, but I'm not doing that in this tutorial, so I don't know. I don't have much. This one's just kind of thrown in there because I forgot to do complex, which I wanted to do last time. Forgot because I forget things. I don't know. I'm human, or maybe not, but I'm led to believe I'm human. Isn't that good enough, man? Come on, give me a break. So you can do um, complex numbers like 2 plus 3j. It's j instead of I know. This is because electricians typically use I for current. I have no clue why. And then they actually use something that makes sense. It's voltage times resistance, and those are actually the beginning of those words. So I don't know where I comes from in current, but that's why they use J typically in at least this programming language. They use J instead of I. You could program it in so you can use I or something, but it's not that way for me. Well, this doesn't really exactly prove that it's actually complex, so what I'm going to do is multiply it by the conjugate and hope that proves it to you guys, that I'm not just fooling around with you guys and just printing off what I just pasted, well, typed. So I'm timesing it by the conjugate. It just negated that j. This happens, if you don't know, when you FOIL these two cancel each other out, and the j ends up being squared, and you get -1 times, in this case, -9, so you'd get 9, so it'd be the positive version. Should I do that manually? Why the hell not? Okay. So you get something like 4, and then because you times this number by this number, and do this number times that number, which would be -6j and plus 6j, right? And then what's after that? You do these two, so you get +9, but I'm actually gonna show it as if I were doing -9 times j squared. J 1 times 1j, and then times 2. I don't know if this will work this way, but I'll try it. Yeah, there we go. We got the same number. So I FOILed correctly, which is crazy. I actually did that wrong on my math final, because I don't know. I felt like bombing it. I don't know. Not really, but I was mostly worried about English that day and making sure I passed that class, because I was about to flunk, because I'm sped, I guess. Okay, now let's pull up, I'm going to show the binary concepts just in case you didn't know. So I'm not going to show too much. Actually, I'm going to show bitwise stuff, so if you're interested. I can't talk and look for what I want. Okay, there we go. I'm going to be using a spreadsheet to show the concept of binary. If you already know, just, I don't know, space off or something. I don't know, I'm usually a spacer, so I don't know, that sounds pretty easy to me. Like, I don't know. So the concept of binary. Binary, you have an octet, which is just like 8 numbers. So when you see like the matrix, they are looking at binary, just 1s and 0s. It's base 2. Most people are used to seeing base 10, and the concept behind base 10 is you're gonna go 1, and then 2, then 3, then 4, then 5, then 6, and then 7, and then 8, and then 9, and finally when you get to 10, then you're going to move it over. With this one, what happens is you're going to go 1, and then after that one's activated, this one will be activated, so that will be 2, and then after, well, then you'll go back over here, and then you'll add 1 there, and then you'll cancel both these out. I know this sounds really bad, but it's not too bad actually. So let's add the decimals above it. Oh yeah, so we can understand this better. So you have 1, 2, 4, 16. I actually like a spacing between these two numbers. Let's position this to the left. Yeah, 32. I really hope I didn't do this wrong. 32, 64. Okay, 128. And then after 128, you have 250. I feel like I'm wrong, because yeah, you can't have 256. 1, 2, 3, 5, 6, 7. Oh, I need an 8. I knew I did it wrong. Oh yeah, 16. Sorry, I'm still sped. Oh, so you just times it by 2 every time. Okay, 64 and 128. Okay, finally I'm done. Yay! Go remedial people like me. Alright, so like, if you'd activate this one, this is normally gonna be like one thing. So I'd have like 0, 0, 0. Look up here, not down here. Alright, and then I'd have like 0, 0, 1, and that would be equal to 1, because that's the only one that's activated. But let's say there was one like that. So you'd have this one activated. So you'd have your 4 and your 1 activated. This would make it 5. So I think you guys get it. Like if this was activated, you'd add 128 to your running total. Did I put 5 there? Wow. Oh well. So yeah, that's pretty much just basic binary. I'll show what anding is. Here's the concept behind anding. It's gonna be like, I'm not even gonna put full octet. What the hell? There. Let's say we had another one. Alright, what anding's gonna do is it's gonna only activate a switch if this one, or a bit, if you wanna be like that. So this one would be activated. So every one of these would, because this one's full. But let's do like, I don't know, 0, 1, 0, 1, 0, 1, 0, 1. And let's do 1, 1, 0, 0, 0, 0, 0. If it's and, then this would be the only one that's activated, because this is the only place where both are activated. Or, that's either or. So this one, like all of them would be activated, because it's either or. So let's just say this one was a 0. Then that'd be the only one that wasn't activated, but if I made that one a 1. Since this is like a 0 and then a 1, one of them is activated out of these two. This would be activated, so that's the concept of OR. An explicit OR is only OR. So the only ones for this would be this one and this one and this one. So I'd have something like, oh, this one. 1, 0, 1, 0, 1, 0, 1, 0. Not too bad, I guess. So that's explicit OR. So that's all the concepts for bitwise. I'm actually going to leave this table up because